Hello students, my name is Ganesh B. Agalave, Assistant Professor in Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. Today we will see convection and its numerical, means how to solve the numerical, its methodology. Learning outcome. At the end of this session, students will be able to solve convection numericals. We will see numerical statement. Now, in the numerical, it is given water is heated while flowing through 1.5 centimeter by 3.5 centimeter rectangular tube at velocity of 1.2 meter per second. The inlet temperature of water is 40 degrees Celsius and tube wall is maintained at 80 degrees Celsius. Determine the length of tube required to raise the temperature of water by 35 degrees Celsius. Use the following correlations and properties. Density is given, thermal conductivity, kinematic viscosity, specific heat, and the correlation is also given. Now, in the convection numericals, first of all, you try to find out the type of numerical. Is it a free convection or forced convection? Now, remember, when velocity is given, so we can consider it is to be forced convection. This is the first point. Second point, in the correlation you observe Reynolds number is provided. Means what? It comes under the forced convection. And as you know, for the free convection, it is, yes, Grashof number. Now, in the solution, first of all, you should draw the schematic diagram. They have given in the statement 1.5 by 3.5 centimeter rectangular tube is provided. So, this is a rectangular tube of 1.5 centimeter by 3.5 centimeter. Such type of tube will be there, and through this the water is flowing at the velocity 1.2 meter per second. The inlet temperature of water fluid is 40 degrees Celsius. So, this is TWI, which is equal to 40 degrees Celsius. And tube wall is maintained at 80 degrees Celsius. Now, as we have performed experiment on forced convection, we know that how to heat the wall by using the band heater. Either there will be plate heater or band heater. So, using the band heater, they have maintained all the surface of this pipe at 80 degrees Celsius. So, this is nothing but surface temperature. It is 80 degrees Celsius. It is assumed that the surface temperature anywhere along these four sides, this is the top side, bottom side, right hand side and left hand side, will be having same 80 degrees Celsius temperature. Now it is to be determined, the length of the tube is to be determined. Okay. Then what else is given? The raise of temperature of water is by 35 degrees Celsius, means outward water temperature will be 40 plus 35. It becomes 75 degrees Celsius. Then, now the reference temperature is bulk mean temperature. So, what is the bulk mean temperature? Bulk mean temperature is the average of inlet fluid temperature plus outlet fluid temperature by 2. So, it comes as 57.3 degrees Celsius. If you substitute it like 40 plus 75 by 2, it comes as 57.3 degrees Celsius. Okay. So, this is the surface temperature, this is the bulk mean temperature. Now, water is getting heated as this is the constant wall type of the numerical. If the given data is absent, then using the data book at bulk mean temperature, the fluid, here water properties are to be obtained. Now here they have given, so there is no question. So which properties are given? Density is given, kinematic thermal conductivity is given, kinematic viscosity is also given, specific heat is also given, and one more property we required, that is Prandtl number. So what is Prandtl number? Mu Cp by K. If you substitute the mu Cp by K, you will get either 0.6 something, 0.687 etc. You will get the Prandtl number, or in the air property table it is provided. Here water is the fluid, so refer the water property table. Now what is the next step after getting all these properties of the fluid from the data book? Is referring the correlation. Given correlation is Nusselt number is equal to 0.023, Reynolds number raised to 0.8, and Prandtl number raised to 0.33. Now I will be substituting the equation of these dimensionless numbers in this equation itself. So it is Nusselt number HLC by K is equal to 0.023. What is the Reynolds number? You have studied in the fluid mechanics. Yes, it is rho VLC by mu raised to 0.8. Prandtl number just now we have discussed. So substitute the Prandtl number value over here. You will get 0.33. Okay. Now here velocity is provided, that is 1.2. Now from this equation you will get the convective heat transfer coefficient. How? You see here. So H into LC. What is the characteristics length? Characteristics length is 4 times cross sectional area divided by perimeter. Now for this case, for the rectangle, characteristics length means equivalent diameter. When circular cross sectional pipe is not given, then odd shape is to be converted into equivalent pipe, that is called as the characteristics length. Here this is the 4, cross sectional area is A into B divided by perimeter is 2 times A plus B. If you substitute these values in meter, 1.5 centimeter is nothing but 0.015 meter, that is A value, and B, this is 0.035 meter. You substitute here, you will get the characteristics length as 0.021 meter. 0.021 meter. Okay. Now you substitute here that 0.021. Okay. That will be in the meter. Then see, if the given cross section of the pipe is circular, then for that case characteristic length for horizontal pipe is, yes, you are correct, that is D. So LC will be equal to D for horizontal pipe. Okay. Now thermal conductivity is 0.653 is equal to, this is 0.023 in the bracket, density value is 985.5 into velocity is 1.2 meter per second is given, multiply by characteristic length is 0.0214 divided by mu. See, as density is given, rho is given, nu is given. So what is mu? Mu is the viscosity. Kinematic viscosity is equal to density divided by mu. Okay. Kinematic viscosity is 0.517 into 10 raised to minus 6 is equal to density is 985.5 divided by mu. From this you will get mu value. So that mu is around 0.5 into 10 raised to minus 5. Okay. Now raised to 0.8 multiply by Prandtl number 0.67 raised to 0.33. If you do this, then you will get H as something. You do the calculation, you will get the H as 5900. And what is the unit? Watt per meter square Kelvin. Okay. Now here we require to find the length. How to proceed now? As you know, there is rise in the temperature of water. So heat absorbed by water is equal to mass of water, Cp of water, temperature of water outlet minus temperature of inlet water. Mass of water not mentioned, so you assume to be 1 into specific heat of water is given 4.19 into 10 raised to 3 and temperature difference is 35 degrees Celsius. So you write here multiply by 35 degrees Celsius. Here if you substitute temperature in degrees Celsius, difference is as same as that of the Kelvin. Okay. So if you do it, you will get some value. Now this heat transfer is by means of convection, so which is also equal to convective heat transfer. Now what is the equation? What is the equation for convective heat transfer? It is HAS. What is AS? Surface area in the bracket surface temperature minus bulk mean temperature. Okay. Now here cross sectional area, surface area is its perimeter. So surface area is equal to 2A plus B into L. You substitute here, you will get the L as 6.3 meter. Okay. So in this fashion you could solve the numericals based on the convection, and this is the standard methodology. First of all, drawing the figure, writing the formulas and finding. For further calculations and for further numericals, you can refer heat transfer by Sengel.